In this video, I'm going to talk about the characteristics of the parent functions for sine and cosine. First of all, this is the parent function for cosine, and this is the parent function for sine. What I want to do first is I want to look at the domain of each. I can see that both of these go on and on forever to the left and to the right, and there's no x values that aren't going to be shaded. So the domain for both is negative infinity to positive infinity, and that will be the case for every sine and cosine graph. Then I want to look at the range of each of these functions. So that's all the included y values. What I'm seeing is that these graphs go in waves back and forth and back and forth and back and forth. From their lowest, their minimum is -1, and their maximum is +1. So I know that the range for each of these, and that's the case for both cosine and sine, is -1, which is included, so I put a bracket on it, to +1, which is included, so I put a bracket on it. That's because the minimum of each of these graphs is -1 and the maximum is +1. Then I'm going to talk about the amplitude. So the amplitude of the graph of each function is going to be 1/2 of the difference of the maximum value and the minimum value. What it is, visually speaking, is the middle of the graph to the top of the graph, or the middle of the graph to the bottom of the graph. So it's the distance between the middle and the top of a wave or the bottom of a wave. That's what amplitude is. Maybe you've seen that before in science. In order to calculate it in the parent functions, what I'm going to do is I'm going to do 1/2 of the difference between the maximum and the minimum. So the maximum is 1 minus the minimum, which is -1. And this is my max, this is my min, and I'm going to see that that gives me 1/2 times 2, which is just 1. So the amplitude of these graphs, or the distance between the middle and the top of the graph, is, as I can see, 1. And it's already told me right there. The next thing that I want to talk about is that each function is periodic, which means that its graph has a repeating pattern. And the repeating pattern that I see is, I'm going to start at the y-axis. For the cosine graph, I'm starting at the maximum and then going down. And then I want to see, where do I see that happening again? Because I can tell that there is something repeating over and over, and I want to see what shape is that. So I'm going to look, where's the next maximum where I'm going down, and where I see that next is at 2 pi. So what I can see is that the pattern that's going to be repeating itself for cosine over and over is this shape here. That's where I start repeating the pattern again. And I call that a C shape. And I call that a C shape because cosine starts with a C, even though it looks more like a U, because it's easier to remember. So the thing that's repeating, the shape that's repeating for a cosine graph, is a C shape. Then if I look at the sine graph, I'm starting at the origin and then going up. So I want to see, where do I next start at the origin and go up? Well, here I'm at the origin, but I'm going down, so that's not it. Here I'm at the origin and I'm going up. Okay, well then that's where the pattern starts repeating again. So I'm looking at this shape here. This is the shape that's repeating over and over and over. And that I would call an S shape, even though it's not a perfect S shape. It just is easy to remember because sine starts with S, just like cosine starts with C, and I think C shape is the thing that's repeating there. That shortest repeating portion of the graph is called a cycle. So this here, from here to here, that C shape is called a cycle. And the horizontal length of each cycle is called a period, which I see here, a period. So the length of a cycle is a period. And a period for, so that repeating shape, where I see it, or the length of it, is 2 pi, both for cosine and sine graphs. So that's what I'm going to keep in the back of my head, that I know for the parent function, the period is 2 pi for cosine and sine. Then I want to look at where the x-intercepts are. So the x-intercepts for y equals sine of x, so that's this graph here at the bottom, occur when, well, let's look. I have one at 0, one at pi, then 2 pi, negative pi, and negative 2 pi. So where x is equal to 0, plus or minus pi, plus or minus 2 pi. If I continued this graph, that pattern would continue, plus or minus 3 pi, plus or minus 4 pi, etc. And then the x-intercepts for the cosine graph, I see at 0, at pi. Nope, just kidding, I don't see it there. What am I saying? I'm being crazy. I see my x-intercepts are at negative pi over 2, negative 3 pi over 2, pi over 2, and 3 pi over 2. So these are my x-intercepts for that. I got confused because I drew these things. I was looking at the wrong thing. Okay, so those are my x-intercepts for the cosine graph that I have there. And that is where the x values are plus or minus pi over 2, plus or minus 3 pi over 2. And then if that pattern continued, it would be plus or minus 5 pi over 2 and plus or minus 7 pi over 2. So basically, all the places where I have all of the places where I have 2 in the denominator and an odd coefficient in the numerator. 1, 3, 5, 7, etc. Another thing I want to talk about is if I have, this is the basis for, if I have coefficients in front of cosine or sine graphs, either on the outside or the inside, it's going to affect the graph, so change it from the parent function. Amplitude I can always find by looking at whatever the a value is. That's the coefficient in front, and doing the absolute value of that. The period is going to be affected by if there's a coefficient inside of the function. So if there's a coefficient inside of the function for cosine or sine, then I'm going to find the new period by doing a regular period of a sine or cosine graph, the parent function. I'm going to take 2 pi and I'm going to divide by the absolute value of b, whatever it is. So let's use that to do these 2 examples here. Before I do these 2 examples here, I just want to point out one more thing, and that one period is split into 4 important pieces. So I have pi over 2 is the 0 to pi over 2 is the first piece, and then pi over 2 to pi is the second piece, and then pi to 3 pi over 2, and then I have 3 pi over 2 to 2 pi. So I can see that this is split, one cycle or one period is split into 4 sections, and that is how I'm always going to do the graph. So what I want to point out is that periods are cut in 4. So when I'm scaling my axis, I need to keep that in mind. That those are where I'm concerned about the minimums and maximums, where they are and where the x-intercepts are. So I'm going to do this first example. I want to graph y equals 4 sine of x. In order to do that, I want to look at what is my coefficient for the graph for the function, and that's 4, and this is going to tell me the amplitude. And then I want to look at what is the coefficient for the inside. Well, the coefficient for the inside in front of the x is 1, which means to find the period, I would do 2 pi over 1, or just get that the period is 2 pi. And if the period is 2 pi, that means if I cut that into 4, I'm going to count by 2 pi over 4, or pi over 2, just like I did in my parent functions up here. The graph was scaled by pi over 2. And So I'm going to do that here. What I'm going to do is I'm going to take pi over 2 and I'm going to multiply by 1, and that's going to be my first thing that I put on my x-axis. Then I'm going to take pi over 2 and I'm going to multiply by 2, and that will be the second thing. And then pi over 2 and I'm going to multiply by 3, and that will be the third number. And then pi over 2 and multiply by 4, and that will be the fourth number, etc. So the scale is going to be, when I do that, I'm going to put pi over 2 as the first thing, then pi over 2 times 2, which is pi, then pi over 2 times 3, which is 3 pi over 2, and then pi over 2 times 4, which is 2 pi. And that will be how I'll scale my graph. What I also want to keep in mind is that I have sine is going to be a S shape that starts at the origin. So it means it starts at the origin, or a 0, 0. I also can see that I have a positive coefficient. So that means that I'm going to do the same thing as I was doing in the parent function, in that I was going up from the origin. If it had a negative in front, we know from algebra 2 that would flip things upside down, and then I would be going downwards. So I know that it means that I'm going upwards from, or to the right of 0, 0. And then I also know from this 4 in front that the amplitude of this graph is 4. So I'm going to keep all of that in mind when I'm graphing this. First, I'm going to start by scaling my x-axis. So I know that my scale is this, and this is what I'm going to be putting down. So I'm going to do pi over 2. I'm just going to do this in black so it's nicer and we can see it better. I'm going to say this is pi over 2, then this is pi, then this is 3 pi over 2, and then this is 2 pi. Oops. 2 pi. And then on this side it would be negative pi over 2. And then what I'm going to do is I'm going to start at the origin. I'm going to put a point here. I know that at pi over 2, instead of my maximum being at 1, now it's going to be at 4. So I'm going to actually have to change the scale on the y-axis as well. I'm going to count by 2's. So this will be negative 2 and this will be negative 4, so that I can put the amplitude in the right place. I'll have a point at pi over 2, comma 4. I'm going upwards because of this. And then at pi, I'm going to have an x-intercept here. At 3 pi over 2, I'm going to be at negative 4. And at 2 pi, I'm going to be at y equals 0. And then if I were to put something on negative pi over 2, I would continue that pattern. And it would mean that I was going to be at, negative 4. And so when I connect the pieces of this graph, this is what my waves will look like. And they're not perfect. They should not be straight in any way. They should just be curves. And that's what my graph will look like. Most of the time when you graph sine or cosine, you're expected to graph 2 periods. In this case, I just graphed 1 and a little bit extra. For the second example, this is going to be a little different because I have 2 pi in front as the coefficient inside, which means to find the period, I'm going to do 2 pi divided by 2 pi, which gives me that the period is equal to 1. So I know the period is equal to 1, which means I should be counting by 1 divided by 4, or 1/4. And so I'm going to do that for my scale. I'm going to do 1/4 times 1 to find the first thing that I'm going to put here. Then 1/4 times 2 to find the second thing that I'm going to put here. Then 1/4 times 3 to find the third thing. And then 1/4 times 4 to find the fourth thing that goes here on my scale. So my scale will be then 1/4 and then this will be 2/4 or 1/2, and this will be 3/4, and this will be 1/4 times 4, which is 1, and so I'll have 1/4, 1/2, 3/4, and 1, and then this over here will be -1/4. From there, I can see my scale is counting by 1/4, which is what I wanted, which is what I said I wanted to count by, because I want to divide the period into 4 pieces. That's where my maximums, minimums, and x-intercepts are going to be. So I'm going to start at I forgot to do the amplitude. The amplitude I know is going to be 1/2, and I have a negative in front, which means a reflection over the x-axis. So first of all, because it's cosine, in general, I know that I'm going to be starting, means I start at the maximum, and the max is going to be at 0, 1/2, except this is flipped upside down. So I'm actually going to be starting at 0, -1/2, and I'm going to be going upwards instead of downwards from that point, because everything was flipped upside down. So I'm going to be at 0, -1/2, that's like right here. And then the next important point is going to be I'm going to be going up from there. So if I'm starting at the minimum, I'm going to be going up from there. And I'm starting at the minimum here instead of the maximum because I flipped upside down. Then at 1/2, I'll be at 1/2. And then at 3/4, I'll be back at the middle. And then at 1, I'll be at -1/2. If I were to put something on -1/4, it would be at 0. And so what I'm going to see is this wave like this, and that is what my graph looks like.